Hello everyone, this is Mr. Wolf here, and in this video I am going to be discussing video modeling round 2, scenario number 1. So this is the second round of video modeling, and in this scenario a plastic strip, a positively charged plastic strip, is going to move close to a pithball, and the question is, are they going to be attracted to one another, repelled from one another, or is just nothing really going to happen? So let's first talk about our objects. We have our plastic strip, and this is going to be an insulator, which means electrons just really can't move around very easily in my material. Now, specifically, it's a positively charged object, which means that it has less electrons compared to protons. All right? Now, it has a charge of positive 4, which means it's missing 4 electrons. And since my object is an insulator, that charge is localized. It's kind of clumped in one area. So notice that I have just this area. It's really just this area of my plastic strip that has that positive charge. All right, my next object is going to be the pithball. This, since it's metal, made of aluminum, it's a conductor, right? And which means the electrons can travel freely throughout my object. Now, right now, my object is neutral. There's an equal amount of protons to electrons. 10 protons, 10 electrons. All right, now, in our scenario, we're going to say that these objects are really, really far apart to begin with. But then what we're going to do is we're going to bring the insulator, all right, closer to the pithball, but not touching, so just close. All right. So then we want to ask the question, well, what do electrons want to do? Right? And the electrons in my pithball, all right, are attracted to the are attracted to the exposed protons in my plastic strip. Even though they're not touching, they're still attracted. All right. The electric force, you don't have to be touching to exert that force. That could be exerted over space. So these electrons want to move as close as they can to this positive part of my plastic strip. Now the next question is, well, can they move? And since this is a conductor, absolutely. So the electrons are going to start to move as close as they can to this positive side of my strip. Now, remember, electrons over here might also want to move. So maybe they kind of fill in these spaces right here. And now that these electrons, these extra electrons have left my atoms on this side over here, then I'm going to uncircle them and make this unneutral. I'm going to uncircle these atoms, make them unneutral. And we still have some neutral atoms in the middle of my conductive pithball right here. All right. Okay. So that's how electrons are going to move. So if I were to look at the overall charge of my object, no electrons left my pithball, no electrons went to my pithball, so the overall charge of my pithball is still neutral. Right? But clearly, something changed in my scenario. Electrons moved over to this side of my pithball. So what I could say is, on this side of my pithball, I have more electrons than protons. I could say that this is negatively charged. On this side of my pithball, there are less electrons than protons. I could say that this side is positively charged. Right? So this is going to be electron shifting, an example of electron shifting. And the question we have in this problem is, now, even though the plastic strip and the pithball aren't touching, what's going to happen? Are they going to attract, repel, or nothing? Now, if this side of my object is negative and my insulating strip is positive, opposites attract. So even though they're not touching, because electrons shifted over and made this side negative, my pithball is going to start to move over towards that plastic strip, even though they're not touching it.